Hello dear students and welcome to Diksha Vedantu Foundation channel, and you are watching Score Booster for your class 10th midterm. So if you are preparing for your midterm, which is going to be started very soon, and you are looking for some extra help, some important questions, some tips and tricks, then you are at the right place. Here in our class 3 we are going to discuss about light reflection chapter. If you have already completed the chapter and you are looking for some important questions, then I will help you to score maximum number of marks possible from this chapter and also the other chapters that may be in your midterm syllabus. So let's start with the basic chapter review. So what all are there in the chapter? First of all, reflection of light is there. Okay, in reflection of light, laws of reflection. Then what is laws of reflection? Incident angle equals to angle of reflection. Then spherical mirror, basic spherical mirrors are there. Convex mirror, which is bulged outward. Concave mirror, which is bulged inward. Now there are image formation by these two mirrors also. Convex mirror always produced virtual and diminished image. Concave mirror can produce virtual as well as real images. We will see that in a while. Also mirror equation, problems related to mirror equation. So mirror equation is 1 by b plus 1 by u equals to 1 by f or equals to 2 by r. Both are correct, and the magnification is given by minus v by u. So this is the chapter overview, and if you are wondering that I cannot remember all those things, then don't worry. You can go into the link given in the description and download the class PDF that is available in this website. From this website you can easily download the class lecture, everything along with the notes, along with the problems, homework, everything will be available in this website. So don't forget to check the link given below. Now first of all, let us start with the basics of light. So one MCQ based on that. Light is a form that gives us the sense of dash. So what is light? Light is a form of what? Force, sound, energy or particles. Obviously light is a form of energy and it gives us the sensation of vision, right? So this is the basic definition of light. So let's start with the basic definition of light. Now let's move on. Let us look into the reflection of light. A small answer type question. What is reflection of light? When light traveling from one medium to another medium, a portion of the incident light bounces back to the first medium from the boundary separating the media. So this is known as reflection of light. So suppose light is traveling from one medium. This is medium number 1. This is medium number 2. For example, light is traveling from air to water or from air to glass. Okay, when light incident on the first medium, after falling on this boundary, this is the boundary, that is the line, very thin line which is separating these two medium, some part of the light bounces back into the first medium. So this is called reflection of light. So now there are few laws that has to be obeyed when you are talking about reflection of light. So let us start with laws of reflection of light. First law, if theta I is the angle of incidence and theta f is the angle of reflection, then which of the following is correct? Theta I can be equals to theta r, theta I can be equals to 2 theta r, or 2 theta I equals to theta r, or theta I greater than theta r, greater than equals to theta r. So which of them is correct? So as we have learned that the angle of incidence is equals to angle of reflection, so correct option is option A. Okay, you can see that in the image that when light is falling into the medium and it is reflecting back to the first medium, then this is called incident ray, this is called reflected ray, this is called angle of incidence, this is called angle of reflection, and these two angles should be equal, right? Now let's move on. Second law of reflection of light. A ray of light is incident on a plane mirror at an angle. No, this is not second law, this is the first law only. Another problem based on the first law. A ray of light is incident on a plane mirror at an angle of incidence 15 degree. The deviation in the ray produced by the mirror is. So what is the deviation produced by the mirror? Very common question. So what is the question? Let us understand that first. So we have a mirror. Okay, light is reflecting at an angle. So to measure the angle, what we have to do? We have to draw a normal at the point of incidence, right? That is, this line is called normal. Normal means 90 degree. right? Now this angle is called angle of incidence. So angle of incidence theta I is given as 15 degrees. Okay, they have asked you what would be the angle of deviation. So after incidence it will be reflected, right? It will be reflected back, and that angle of reflection will also be equals to 15 degrees. Right? Now what is that angle of deviation means? Angle of deviation means, suppose there was no such media present, then what will happen to this ray? This ray would have gone in a straight line, right? Light travels in a straight path, rectilinear propagation of light, so light would have traveled in a straight path. So this angle by which it deviates is called the angle of deviation. Say angle D, or you can write it as delta also, whatever you want. Okay, I am writing angle D. Now what is the angle D? Now if you know that this angle, this entire angle is basically, this entire angle is 180 degree, right? So this entire angle is 180 degree. Okay, now from this 180 degree angle you have to subtract this angle. You have to subtract this angle to find the angle of deviation. So angle of deviation, angle D, is basically 180 degree minus theta I plus theta R, that is another theta I, so it will be 2 theta I. Simple formula. Okay, so 180 degrees minus 2 times 15, so it will be 180 minus 30, so it will be 150 degrees. Okay, simple problem, simple answer. Don't worry, it is very simple, going to be simple. You will score maximum possible marks. So don't worry about if you are wondering how you can score marks, right? Now let's look into the second law. To answer the second law, it is an assertion and reason based question. Incident ray, the reflected ray, and the normal drawn at the point of incidence all lie on the same plane. So is it correct? Yes, it is correct, because this is a second law of reflection. So it is a true statement. So whenever you see a true statement, write it true. Now law of reflection is not valid for rough surfaces. First of all, is it a reason of this? Obviously no, does not seem any connection between them. Now also, is it a correct statement or not? This is not a correct statement, because law of reflection is valid for all type of surfaces. Law of reflection is valid for all type of surfaces, so this is a false statement, right? Now if you see which what one of them is correct, assertion is true, reason is false. So correct answer is option C. Don't worry, don't waste too much time on reading all the options. Only you find out what is true, what is false. If it's correct, if both of them are true, then you have to check if it is a correct reason or not. If it is not a correct reason, if you think it is not a correct reason, then option B would be the correct answer, right? Now let's move on. Different types of images. There are two types of images we know. First is, what is a virtual image? So if the light rays do not meet after reflection or refraction but appear to meet when produced backwards, then the formed image is called a virtual image. The image cannot be obtained on a screen. For example, when we see ourselves in a mirror, okay, so when we see ourselves in a mirror, what happens in the mirror is that the light from a source, for example light from a source, they come, okay, and they, after reflection, they do not meet at some point, they just simply go back, right? Now what you have to do to find the image, you have to trace them back and you have to say, okay, this is the image, right? This is the image for this object, right? Now if these two rays actually meet, no matter how long you have to take, if they actually meet at some point, then it would have been a different type of image. But since they are not meeting, only way to make them meet is to take them backward, then this is a virtual image. Right? Virtual image, the rays actually do not meet. Now next type of image is, what is a real image? If the rays do meet after reflection or refraction, the image can be obtained on a screen, then that formed image is called a real image. So in case of virtual image, the image cannot be obtained on a screen, whereas for real image it can be obtained on a screen. So that is the basic difference also. So if they ask you what is the difference between virtual image and real image, that is also you are good for that. So what is real image? After reflection or diffraction, if the rays do meet, so suppose the rays after reflection or refraction, okay, they do meet at some point and you get an image which can be obtained on a screen. So if you place a screen here, you can get the image here. So that is called a real image, right? I will teach you all the tricks how to draw the ray diagram, specifically when you are drawing ray diagram, when they have asked you to draw the ray diagram, that I will also going to be explained in this lecture. Now let's start with image formation by convex mirror. The first one, convex mirror. So a mirror forms a virtual, erect and diminished image of an object. So what are all the properties of the image? Virtual, erect and diminished. So all these three are possible only for which mirror? Yes, you have guessed it right, only possible for convex mirror. So in case of convex mirror, the image is always virtual, okay, image is always erect and image is always smaller than that of the object, that is, it is called a diminished image. Now how you can draw this ray diagram? So whenever you are drawing a ray diagram, remember that first you have to start with the principal axis. So this line is called principal axis, okay, this line is called principal axis. Okay, and this is the mirror. In the mirror there is, you have to use this, you cannot draw like it is given in your book. So what you have to do, first you have to draw the principal axis. Now in case of convex mirror, okay, first of all, first point that you need to consider is center of curvature C, first point. Okay, so as much as possible on your left hand side of your paper, you have to use your compass. Okay, in the compass use a small size pencil, do not use a long sized pencil. Pencil should be small and it should perfectly fit into your compass, and you can tighten it and still you can balance it. Okay, I hope you know how to balance the compass. Okay, and do not use a large size pencil. If it is a new one, you have to cut it from the middle so that you can get a sufficiently sized pencil, right? If you have an old pencil, that is very good. Okay, you can use that for your compass purpose, right? Now when you are drawing a convex mirror, okay, convex mirror is like this, right? So bulged outward, right? So first you have to take the center of curvature. First you have to start with center of curvature, okay, then measure a distance. Using your scale, measure a distance. I say measure a distance, say 8 centimeter or 10 centimeter based on the width, how you are drawing, if you are drawing vertically or if you are drawing horizontally. Okay, I request you, if you can fold the paper and draw it like this, then it will be very good. So in that case, if you are drawing it upright, then you have to take the distance as small. If you are flipping it and drawing it, then you can take a little bit longer distance. Okay, so I say take a distance 8 centimeter. Okay, now you are starting at point C and you measure a distance, say 8 centimeter. Okay, and then you also mark the middle point, that is 4 centimeter. You have to mark these points using your scale first, before even if you touch your compass. Compass is balanced, compass is fixed, right? Now take your compass and draw the curve. Take your compass, put at center of curvature. Your needle should be at the center of curvature, right? And then you have to draw the mirror. Okay, now once your mirror is completed, then you know this is a convex mirror, so you have to mark this as shaded part. Okay, now mark this as F using your pencil, mark this as pole. Okay, now what you have to do, you have to take an object. So first object, take a little bit, for convex mirror take a little long object. Okay, now first ray that you have to consider is to draw a parallel ray. So adjust your scale. Okay, take the scale so that you can draw the parallel line equally. Okay, now once the parallel line is drawn, then join this point and this point. This is point 1. Okay, this point should be joined with point 1. I am marking them so that you don't get confused. Okay, now you have to, using your scale, you put your scale, okay, like this, and back side you do the dot, and in the front side you extend it. Same line you extend it, okay, in this side. Now second ray, what you have to do, you have to take this point, okay, and this point. You have to join these 2 points, okay. So you have to join these 2 points, okay. Here on this side you have to join them, on the behind you have to use dotted line, okay. Now you have to put the arrows. In case of second line, you put the arrow forward as well as backward. Remember that. Now whenever they intersect, that point should be your image. This should be your image. So here you have to use another arrow, okay, because it is upside, so you have to draw the arrow in this direction, right. So this is your final image, right. So you have obtained the image for this given object, right. This is the way you have to draw. I will teach the same thing for concave mirror also, don't worry, okay. There are few tricks for concave mirror. Convex mirror, it is very simple. Only one method you have to remember, that while drawing the image you have to consider these 2 points first, then these 2 points, okay. These are the points that you have to consider, right. Now let's move on. Now if you see, this is a virtual image, this is diminished image, and also it is erect image, right. Now they have asked you to identify the type of this mirror. So type of this mirror is convex mirror, okay. Type is convex mirror, okay. Now this is a basic table for your objective, for your MCQs. This table may be handy, especially when the object is an infinity, okay. The image is highly diminished, point sized, but most importantly it is virtual and erect, okay. Now you might be say that, sir, how do I know it is actually erect or not? Yes, correct question, but if you somehow magnify that obtained image, then you will see this is a erect image, okay. So there are some ways that you can, even if it is highly diminished and point size, you can magnify that after it is formed, okay. There are some ways. So in that way you can say, okay, this is a erect image. At the focus, okay, obviously at the focus behind the mirror, okay. Now in any other cases between P and F, okay, behind the mirror always, and it is diminished, okay, not point size, not necessarily point size, we have seen that, okay, but it will be virtual and erect. So the mirror that which always forms virtual and erect image is convex mirror, okay. So sometimes they might confuse you that virtual and enlarged. Virtual and enlarged is not possible by convex mirror, okay. So virtual and erect image is only possible by virtual and erect and diminished image is only possible by convex mirror. Also remember that all the virtual images will be erect. We will see that in future also. Whenever we are talking about virtual images, they are always erect, okay. There are no cases where you will see inverted image when you are seeing a virtual image, okay. Real images generally inverted and virtual images generally erect, okay. This is one way to identify if they say an erect image. Erect and diminished image, they have not mentioned virtual image. Erect and diminished image means it has to be a virtual image. That is also some information that you should remember. Now let's move on to another question. Why do we prefer convex mirror as a rear view mirror in cars? So what is the rear view mirror? If you have seen a car, there are some mirrors added to the side, okay. You might be thinking why they have added mirrors in the sides, maybe to fix the hair of the driver, okay, or maybe to fix the hair of the passenger. No, actually it has a very important duty that when you are driving on the road, you can see whoever is driving on your right hand side, whenever someone is driving on your right hand side or someone is driving behind you, so everything can be visible from the rear view mirror, right. So rear view mirror plays a very important role. It is a part of the safety feature of the car, that when you are taking a turn or when you are giving side or you are taking right side or left side, then you have to check your rear view mirror so you don't get collide with any other passengers, any other cars that may be on the right hand side or left hand side, right. So but instead of using plane mirror, which is very clear, we are very easy to manufacture as well, why we use convex mirror? So there is a very important role that it has a very high field of view. So what is the field of view means? For example, if I am using a plane mirror, okay, so light ray is coming from this side, light ray is coming from this side, okay, and they are forming image, but they will be the field of view will be very small. But if you are using a convex mirror, okay, light coming from this side also, light coming from this side also, everything can be seen from this mirror, okay, because also it forms images closer to the mirror. Okay, so that is another advantage, that a large portion of objects can be seen from this mirror. Okay, that's why this mirror is used in rear view mirror. Okay, so because it has a very large field of view, means it can see a very large distance, large area behind the mirror. So that's why it is used in rear view mirrors. Now let's move on. See one example. It is desired to obtain an erect image of an object using a concave mirror of focal length 12 centimeter. Now it says that erect image, okay, it has not mentioned virtual or real, okay, but it has mentioned concave mirror. So we already discussed that for erect image, what type of image it is? It is a virtual image, right? So what should be the range of the object distance in the above case? So first of all, let us understand the concave mirror. In case of concave mirror are like this, right? So this is the concave side. Concave mirror, when you place an object with the distance less than the focal length, then it forms a virtual image. We already know that, right? So this is pole, this is F. If you put the object between F and P, then you will get a virtual image. So if you put the object here, you will get a virtual image, which is basically an erect image, right? So the answer will be, the range of the distance should be from 0 to 12 centimeter. So 0 means this is 0, this is 12, right? So we will discuss about the sign convention as well, where we will discuss why this is 0, why this is 12. Okay, but you should remember that pole is always at 0. For any mirror, convex, concave, pole is at always 0, right? Now the distance should be 0 to 12 centimeter. Now this is one of the question from your previous year questions. So if you are thinking why sir is giving such questions, because this is important question. Okay, this came in one of the sets in your previous year, right? Now let's move on to the second part of the question, same information, but the question is different. Will the image be smaller or larger than the object? Draw a ray diagram to show the formation of image in this case. So first of all, what do you think? It will be smaller image or it will be larger image? So for convex mirror, we know image is diminished, right? For concave mirror, it can be enlarged, it can be diminished, it can be anything. Okay, so but when it is a virtual image, that is an erect image, okay, when it is an erect image, the image is always larger than that of the object. So it is always magnified image, right? So first of all, the image will be larger, and if you draw the ray diagram, then you will see this is the ray diagram. Now how you can draw the ray diagram for concave mirror? So I am going to teach you how you can draw the ray diagram for concave mirror. Now in your previous case, what you have drawn first? Principal axis, right? So in this case also we will start with principal axis. In the previous case, you have taken your center of curvature on right hand side of your paper. Now in this case, same thing, but you have to take the center of curvature on your left hand side of the paper. Try to draw the center of curvature somewhere in the towards the center. Don't take extreme. Okay, if you take the center of curvature extreme end of the paper, then you may not be able to draw the diagram. So always take the center of curvature somewhere in the middle. Okay, for concave mirror. Convex mirror, it is okay, everything is happening behind the mirror and within the focal length, so it is okay. But concave mirror, try to take the center of curvature somewhere here. Okay, if this is your if you consider this is your page, take it somewhere in the middle of the middle. Okay, now you take again 8 centimeter 8 centimeter you take the object, the center you take the focus. Okay, so if this is 8 centimeter, this should be 4 centimeter, and this is your pole. Okay, now you take an object, take a small size object. Here first ray that we have drawn in the previous case also same, it will be the parallel ray. Okay, parallel ray. Then if you mark this as point 1, this ray should be passing through focus. This ray should be passing through focus. So you have to join again 1 1, join 1 1. Okay, then extend it. Similarly, next will be this 2 and 2. If you remember this order, you will never miss any ray diagram. You will be able to draw all types of ray diagram. Same thing. Okay, except one maybe that I will be going to teach you very soon. Then you join these 2 points. Okay, extend it, and whatever ray is going through there, it will come back in the same path. Now if you see, these 2 rays will never meet if you extend them in the forward direction, obviously. So it is a virtual image. So what you have to do, you have to extend them in the back side. After you extend it to back side, they will meet at some point. Okay, if you draw it using a scale, obviously you will draw better than me. I am using my bare hands to draw this diagram, so my diagram is not very perfect, but if you are using a scale, then it will be a perfect diagram, right? So this is the way to draw the ray diagram for concave mirror. So as you can see, the image is larger, okay, and it is magnified. We can say this image is magnified, right? Now let's move on to the third part of the question. Where will the image be formed if the object is placed 24 centimeter in front of the mirror? Another interesting question. Okay, so we know that when what is the 24 centimeter means? 24 centimeter means one more question. Many time I get this question from student is that, sir, the focal length is mentioned 12 centimeter. So do we have to use this distance as 12 centimeter? Do we have to use this distance as 12 centimeter? No, that is a given value. Don't, if they ask you 100 centimeter focal length, will you be able to draw 100 centimeter? It is not possible, right? So don't take these values by heart. You can draw, you can use your own scale, but as long as your focal length is double, your center of curvature is double that of the focal length, all the other laws are being followed, then it is fine. Okay, as long as you can say it's a miniature of that given data, right? So as long as it's a concave mirror with all the things are in place, then you are good to go. You don't need to draw an image where you are drawing, if the 12 centimeter focal length is given, you don't need to draw 12 centimeter actual focal length in your paper. Okay, remember this point. Now, next part. So if the object is placed at 24 centimeter, we can see that 24 is basically double of 12 centimeter. So basically this is nothing but the radius of curvature. So we know that the object distance is actually u equals to 2f, that is object is placed at the center of curvature of the mirror. So thus the image will be at the center of curvature itself, right? So image will be at the center of curvature. So we can say that the image will be at 24 centimeter itself. So answer will be 24 centimeter. So the answer will be 24 centimeter. Okay, this is the image. Image will be formed. Where the image will be formed? Image will be formed at the same position, that is at the center of curvature, that is at 24 centimeter. Whatever you write, you will get full marks. Now, there are few special cases. A common case I have already explained. Now let us see when the object will be real image. In the case of real image, first ray is same. Okay, you are taking this point. I am not going to draw this. I am just going to mark these points. First you have to draw this parallel line and mark this point, say point 1. Then you have to join this point and this point. Okay, join these 2 points. Next you have to join this point, point number 2 and point number 2. Okay, then extend it, and you don't need to do anything else. You just need to put arrows. Also one point you have to remember, that whenever you are drawing a ray diagram, don't forget to put arrows. Okay, without arrows it is meaningless. So right ray is going from in this direction coming this way, or it is coming in this direction and going this way. that is very important. Which one is object, which one is image, that is also very important. So if you are marking them A, B, then this should be B dash A dash. Okay, this is a way of marking the image. Okay, also put 1 or 2 arrows. They have put 2 arrows, you can put 1 arrows along the principal axis. If you are putting 2 arrows, you have to put 2 arrows back as well, right? So the principal whatever ray is passing through the center of curvature, it will come back along the same path. So light ray traveling in this direction, it should come back in the same path, right? And whatever ray is parallel to the principal axis, that should pass through the focus. That is the basic principle of drawing the ray diagram. Now if you have drawn the ray diagram correctly for any position, does not matter. If they say beyond C, you have to take a point which is outside C. If they say between C and F, then you have to take the object here. If they say close than C, you already seen. Okay, less than F, what will happen? Okay, so that also we have covered. Now there is one special case that I want to put your focus on. When they have asked you to draw for object, somehow they have given you data, somehow they have asked you to draw the ray diagram. So for example, in that problem that we have seen, if the object is placed at 24 centimeter, where the image will be formed, show that using a ray diagram. Right? So what you have to do in that case, this is a very special case. They will never ask you directly this question. They will ask you in a form of a question or part question where you have to draw this diagram. This is a very special case because you cannot draw the second point, right? You remember I told you this was my second point, this was my second point. Now they are already on the same line, so you cannot draw that ray diagram. So what you have to do in this case, this is a very special case. Also, even if you follow all the rules, you might not get the desired image. Okay, you will see that your object was somewhere. Suppose your object was here, you will get the image somewhere slightly displaced. Image you will get somewhere here or somewhere here. Okay, so you will not get exactly at the same position, even if there is a small mistakes while you are drawing. Even if you are following, if it is not perfectly parallel, even if it is slightly mistaken, then also your image will not come correctly. So what you have to do in this case, the process of taking the principal axis, taking the center of curvature and drawing the diagram mirror is same. Okay. Focus, I will say, don't mark the focus. Don't mark the focus in this special case. Okay, so this is a very special case. First you have to draw an object of say 2 centimeter like this. Okay, you draw 2 centimeter object upward, and the same position you draw an object 2 centimeter downward as well. Okay, so this is the trick. This is the trick that you have to do. So whatever you are drawing 2 centimeter up, same size you have to draw below as well. That's it. Your diagram is 90% over. Now what you have to do? You have to draw the parallel ray. Okay, you have to draw the parallel ray. And once the parallel ray is done, now what you have to do? This is your point number 1 and this is your point number 1. So what you have to do? You have to join these 2 points. Using your scale, just join them. Okay, next what you have to do? You have to draw a parallel ray. You have to draw a parallel ray in this direction. Okay, now this is your point number 2, this is your point number 2. You have to join them. Okay, now if you see more than once, what will happen? These 2 rays will not pass through this point. Okay, sometimes they will intersect slightly up, sometimes they will intersect some little below. So what you have to do in that case? You have to so for example, in my diagram they have just intersected slightly above. Okay, so if you put the arrows, okay, A, B, or rather BA. Now in this case B and B dash are overlapping. So what you have to, how you can resolve this? You use a dot here. Okay, you use a dot here to hide your failure. Okay, you use a little bit thicker dot and mark this point as F now. Okay, To hide your failure, you have to use. This is a very tricky diagram. If you don't know this trick, you will never be able to draw this diagram perfectly. Okay, now your diagram is done. You will score full marks. I can guarantee that. Okay, even if there are small mistakes, you will get full marks. This is the way to draw this ray diagram, right? Special case. Now let's move on. This is the table for concave mirror. For object is at infinity. In that case, image will be at the focus. It is highly diminished. Okay, point sized. Again, it will be real and inverted. Now same question you might be asking, sir, how do you know it is inverted? You can enlarge it and you can see it. There are different ways. Now similarly, if it is beyond C, that is if it is between infinity and C, what will happen? If it is beyond C, it will be between C and F. Okay, between C and F. Okay, it will be diminished, real and inverted. Okay, now when it's at C, the image will be at C, obviously same size, real and inverted. Okay, now between C and F, it will be beyond C. Okay, it will be enlarged and real and inverted. Okay, now at F, image will be at infinity. Okay, very less used, highly enlarged, real and inverted. Similarly, between P and F, it will be behind the mirror, enlarged and virtual and erect. We have seen that always. So if you see, whenever there is a real image, it is inverted. Whenever there is a virtual image, it is erect, including convex mirror, right? Now let's move on. If you are wondering how can I remember all these tables, how I can remember all the lectures, all the questions that is being discussed in this class, don't worry, the link is given in the description. From that link you can go to the website and download the PDF given in that website. So you will be getting all the class lectures, including solved problems, including homework. Everything will be available in this website. Don't forget to visit the website once you have completed this lecture. Now let's move on. Question number 5. Explain with the diagram about the sign convention of light. So sign convention of light is basically your coordinate geometry. If you remember coordinate geometry, okay, you have drawn this x, positive x, negative x, or sometimes you call it x dash, y, y dash, whatever you like, negative y or y dash. I generally use x, x dash, so I am using x, x dash. Okay, and y, y dash means negative y, x means positive x, y means positive y, right? We know that. And this point is basically your pole, origin is your pole, where, so origin is basically your 0, 0. Now generally distances, object distance, image distance are measured along x-axis. Object distance, image distances are measured along x-axis, and anything on the negative x-axis is negative, anything along positive x-axis is positive, anything along positive y-axis is positive, anything along negative y-axis is negative. So for example, whenever we are considering a mirror, whenever we are considering an object, the object distance is always on the left hand side, that is on the negative x-axis, right? So in that case, what we will do, we will always consider the object distance as negative. Okay, object distance is always negative. Okay, and in case of convex mirror, we see image is always formed on our right hand side, right? So in that case, we will consider that our image distance is positive. Okay, so based on the data, based on the information given to you to solve a problem or answer a question, you have to remember that you have to use the proper sign before starting the problem. Okay, before solving the problem. And initially when I was a student, it was very difficult for me to remember what type of sign I have to use for u. I was always getting confused, plus minus, but this is the easiest way to remember. If you remember your coordinate system, if you remember that anything along positive x-axis is positive, anything along negative x-axis is negative, then your life is easy. Okay, now let's move on. This is the length formula, 1 by v plus 1 by u equals to 1 by f equals to 2 by r, right? So it also gives you a hint that 1 by f is basically 2 by r, or f is equal to r by 2. So focal length is basically radius of curvature by 2. So half of the radius of curvature. R is radius of curvature, right? I hope you know the symbols. V is object distance, V is image distance, U is object distance, and F is focal length, right? R is radius of curvature, right? So these are the all symbols. Now this formula is valid for all situation, including real, including virtual. Okay, for all situation it is valid. Okay, for all spherical mirrors. Okay, does not matter for convex mirror or concave mirror. For all spherical mirrors it is valid for all position of the object. Even if it is infinity, object is at infinity, object is at focus. For all the cases you can put the values here and you will get the answer. Okay, also you must use the new Cartesian sign system that I told you, the sign system that I explained you. Okay, there are some old Cartesian system, there are some different kind of system, but new Cartesian sign system is the accepted system and it is widely used across the universe for now. Okay, whilst substituting the numerical values U, V and F. So you have to find if U is positive or V is positive or F is positive. Similarly, if U is negative or V is negative or F is negative. So in some cases two values will be given and you have to find the third one, right? So for the given two values you have to identify correctly if their sign is positive or their sign is negative. Okay, we'll solve some numericals as well. Okay, and mirror formula to solve problem. So when you are solving the problem you have to use the values correctly. Now let's see magnification. What is magnification? Magnification is basically defined by the height of the image divided by height of the image, right? So what is the correct formula? If you remember at the beginning of the lecture I told you the magnification is given by minus V by U. So the magnification definition is height of the image divided by height of the object and its formula is minus V by U. Now you should remember that while using this formula as well you have to use the proper sign. Okay, so if you are using this formula you have to use whether V is positive or U is positive. Similarly, V is negative or U is negative, you have to use proper sign. And if M is positive, that means object is erect. Object is erect and we know that erect object means it is virtual, right? Similarly, if M is negative, then object is inverted, right? So inverted means it's a real image. Similarly, if M is greater than 1, okay, then it is enlarged. Magnitude of M, basically magnitude of M, I am writing magnitude because in some cases it will be minus 2. Okay, and you will think, sir told me greater than 1, minus 2 is definitely less than 1. Then how can it be an enlarged image? If the magnitude, that is the value that you are getting, 2, 3, 4, 0.5, 0.6, if you are getting the value, if that value does not matter whatever sign it is, the value should be greater than 1 and then we will call it enlarged image. Similarly, value, if the value is less than 1, then it is a diminished image. Okay, you should remember these are the 4 points that you need to remember about magnification. Now let's move on. Let's solve one numerical problem. An object of 5 centimeter high is placed at 10 centimeter from a convex mirror of radius of curvature 30 centimeter. Find the nature, position and size of the image. So first of all, what all are given? The object distance is given, placed at 10 centimeter. So object distance is basically, I always say object distance you should always put a negative sign. Okay, object is sometimes it's called, it is the cursed subject. Okay, so it is always starts with a negative sign, right? Now the radius of convex mirror is given. Convex mirror means mirror is like this, so radius of curvature on other side, so radius of curvature should be positive. So radius of curvature is 30 centimeter, it should be positive. Now you can find F. which is 15 centimeter, or you can simply use the formula 1 by V plus 1 by U equals to 2 by R. Okay, you can directly use that, or you can divide it by 2 and use 1 by F. Whatever you like, both are okay. Okay, now we do not know V, we are trying to find V. U is minus 1 by 10 and it is 2 by 30. So if you see, it will automatically reduce to 1 by F. It does not matter, right? Now, so 1 by V will be equals to, if you take this to the other side, it will be 1 by 10 plus 1 by 15. Now what is LCM? LCM of these two is 10 and 15. LCM is 30. So it will be 3 plus 2, it will be 5 by 30, right? So V will be equals to 30 by 5. Don't forget, it is 1 by V, so you have to invert both of them, both sides. Some students, I have seen that they cancel it here. Okay, they cancel it here and then they write the answer as 1 by 6 centimeter, which is very, very unfortunate. Okay, so V should be 6 centimeter, right? So you have calculated the V. Now we know that magnification is minus U by V. Okay, U is minus V by U. What I am saying? Minus V by U. V is 6 centimeter and U is minus 10 centimeter. So 10 minus cancels, it will be 0.6, right? So what is the size? Now they have not asked you to find the magnification, they have asked you to find the size, because object size is given, right? So size of the object, that is height of the object, is basically magnification times actual height. So 0.6 times 5. So it will be 3 centimeter. Remember this. This is a very trick question. This is also from one of your previous year question. So don't get confused. First of all, you have to find the V. V is 6 centimeter. This is one answer. Okay. And what is the nature of the image? V is positive. So nature of the image is virtual. Nature of the image is virtual. And if it is a virtual image, we also know what else? It should be erect. Virtual, erect, that we can see from this magnification as well. Magnification is positive, so it will be a erect image, right? That is one thing. So nature will be virtual, erect, and position is 6 centimeter behind the mirror. Okay, positive means behind the mirror. Okay, size of the image is 3 centimeter. A ray of light is incident on a concave mirror parallel to the principal axis. If this ray, after reflection from the mirror, passes through the principal axis from a point at a distance of 10 centimeter from the pole of the mirror, find the radius of curvature of the mirror. Very interesting question. This is a part question. So if you know that, if you know, you understand your question paper. So in the long answer type question paper, they have asked you different questions, and the last part, some generalists, they add 2 marks a numerical question. So this is that 2 mark numerical question. This is not an outright 5 mark numerical question. So in this part, what they have asked you, that a ray of light incident on a concave mirror. Okay, it is a concave mirror parallel to the principal axis. So concave mirror, let us understand this question. Okay, then we will start answering this. So parallel to the principal axis. Parallel to the principal axis, we know that whenever there is a ray falling on a mirror parallel to the principal axis, it always passes through which point? I told you, point number 1, right? So it always passes through the principal focus. Now why we call it principal focus, we can discuss that in a later video, but right now you should remember that they always pass through the principal focus. So this distance is given as 10 centimeter. Okay, so what is this distance? This distance is nothing but focal length. So focal length is given as 10 centimeter. So they have not directly told you focal length is 10 centimeter, calculate radius of curvature. That would be very simple problem. But they have given you hint, they have given you information. Based on that you can identify, because it is the parallel ray is intersecting the principal axis at a 10 centimeter. That means the focal length is 10 centimeter. Therefore radius of curvature is basically twice of that. That is 2 times 10. That is 20 centimeter, right? So radius of curvature of this mirror is 20 centimeter. This is a very small problem, but still you can score 2 marks if you understand this question. If you don't understand, array, it is very difficult. You will just scrap your head and you will say, I quit. Now let's look into the homework. Now homework, problem, everything you can download from the link given below. I am giving you the homework. If you don't want to download, you can pause the video here. You can note down the homework, solve it and mention the answers. Question number 1, answer below. Okay. Question number 2, answer below. Okay. And if you don't understand the homework, that also you can mention, okay, I have not understood homework number 2, can you please explain? I will explain. That also you mention in the comment. I will, or anyway, I will be solving this homework in our next lecture, in our next class, okay, where we are discussing refraction of light. During refraction of light, I will be discussing all these questions in detail whenever required. Okay, so don't worry about that. The answers will be given. And this is question number 3, short answer type question. This is also short answer type question. Question number 4. You don't need to mention short answer type questions in the comment below if you don't want, but homework number 1, homework number 2, that is MCQs, you have to answer them. Okay. And long answer type question, this is a numerical, solve it, solve this numerical, mention the answer in the comment below. Okay, so for long answer type question number 5, answer is say 10 centimeter or answer is 25 centimeter. Whatever the answer, you mention that in the comment below. I will be responsible, I will be answering all the queries that you have there, and if you are answering this correctly, I will ensure that you are getting 1 like from me, your answer is correct. Okay. Now this is a very interesting long question. I will explain this question to you. This is a very good question, close to my heart, from your previous year question paper. Again, study the data given below showing the focal length of 3 concave mirrors. Okay, so 3 concave mirrors, mirror A, B and C are given. Focal lengths are given 20 centimeter, 15 centimeter, 30 centimeter, and for all the cases the object distances are also given. So these are the given information. Okay, focal length means basically F is given. I am giving you some hints. U is given. Okay, they are not given in a sign format. Sign you have to apply if you are solving some numericals. So they have only given you in form of distances, right? Now they have asked you first question, in which cases the mirror will form diminished image of the object? Justify your answer, part number 1. So in which case object will be forming a diminished image? So only diminished image is formed when the object is beyond 2C, or sorry, beyond C. Okay, beyond 2F or beyond C. So what is this case? Only one case it will be possible, when focal length is 20 centimeter and object distance is 45 centimeter. So you can see that it is beyond 2C, right? I have already given you the answer for question number 1. Now question number 2, question number 3, similarly you have to answer them and you have to mention that in the comment below. So I have already solved one question for you. Okay, now list 2 properties of the image formed in case 2. So they have asked you to find the properties of case 2 and what is the nature of the size of the image formed by mirror C. So in this case, this is basically a numerical. You have to answer this, you have to solve the question and you have to draw a ray diagram. Ray diagram you cannot, obviously you cannot draw that in our chat. You can, but you can mention which ray diagram you have to draw, that you can mention in the comment below. Okay, now before I go, there is a very important announcement for all class 10 student. If you are thinking what to do after class 10th, and you are confused, one wrong decision can ruin your entire career. So don't wait. Appear for Diksha Scholastic Aptitude Test. Here we will be conducting a 60-minute lecture. After the lecture is over, you will be given an aptitude test, and based on your test result, there will be a one-on-one counselor available to you. He will give you your honest opinion whether you should go for engineering courses or you should go for medical courses, what is suitable for you, or you can go for any other courses. That counselor will give you a very detailed information to you. And if you are wondering how can I get that information, you can register in this link, and you can go to the link given in the description. In that description, you have to go to the website, fill your details, and our representatives will contact you. And if you score well in DSAT, then you will get up to 90% scholarship if you take admission in any of our colleges. So what are you waiting for? Don't forget, go to that link given below and book your DSAT seat today. Now, if you are thinking, how can I get all the class notes, all the homework that is being discussed in this lecture, that is also available to you absolutely free of cost. You can go to the link given in the description. You can download the PDF file of this lecture, and if you are thinking that I am making any difference to your life, then don't forget to subscribe to our channel, and I thank you for watching this video.